Alright, so let's do some dimensional analysis example work together. I'm on the page that says unit conversion using dimensional analysis. I believe it's in your packet. So it says here how many inches are there in 45.6 centimeters. So we want to know inches, and we know 45.6 centimeters. So the first thing I always do is I write what I know. I set that over 1. Now, on the conversions chart that you have in your packets, you would go and find 2.54 centimeters is equivalent to 1 inch. Now, remember, with dimensional analysis problems, we always want to take it and cancel. So centimeters cancels centimeters here. What that does is that leaves us on the very top with, here's my son in the background, with what you want at the end. So 2.54 centimeters and 1 inch. Notice this whole conversion factor gets written together. One thing over one thing. So conversion factors always stay together. The reason it was centimeters on the bottom here is so you could cancel back to this centimeters here. So when you do the math on this, you would take 45.6 times 1, and you would get 45.6. Graham, give me a second. That would be divided by 2.54. Stay back, Graham. Stay back, Graham. You're in my video. All right? So 2.54. So you would take 45.6 and you would divide it by 2.54. So 45.6 divided by 2.54. And you would get 17.95. Now, we're going to talk about significant figures soon. But this thing has 3 significant figures. 1, 2, 3. This thing has 3 significant figures. 1, 2, 3. And so 17.95 has 4 significant figures. 1, 2, 3, and 4. Therefore, when we round this, we're going to give it 18.0. Now, it gets a label, and that label is inches. So your final answer is 18.0. Make another page, a problem on a page. Let's go to the page that says, can you believe it? Mr. Gerbe created more dimensional analysis practice for you. And let's just start at the top. So it says, number 1, there are 100.00 yards on Dutch Stadium's playing field. How many centimeters is that? So we have 100.00 centimeters. Now, when we get to dimensional analysis, you realize all these zeros are significant, so there are 5 significant figures here. And it wants to know, let's see, oh, and that's not centimeters, that's yards, so let's not make that mistake. And it wants to know how many centimeters is in that. So here we go, 100 yards. Well, the first thing I can think about when I think about it, I think 3 feet in a yard. So yards is on the top, therefore I need to put yards on the bottom. And we just said that's 3 feet in 1 yard. So 3 feet, 1 yard. Note the conversion factor goes together. That cancels the yards, leaving us feet. That's not what we want, right? Because we got to get all the way to centimeters. So, got to keep going. Well, in 1 foot, there is 12 inches. Feet cancels feet, leaving us inches. We stopped right now. But that's not what we wanted either. So, in 1 inch, 2.54 centimeters. Inches cancels inches, leaving me centimeters on the top, therefore you are indeed done. And we go ahead and do the math on it. So I'll get out my trusty calculator. I multiply the tops across, the bottoms across. We 1 times 1 times 1 times 1, so it's irrelevant. We have 100 times 3 times 12 times 2.54. And we started with 5 significant figures, so if we can, we're going to give an answer with 5 significant figures. Now, the answer is 9,144. Now, you're going to find that that has 4 significant digits to it. So what we can do is we can add trailing zeros after a decimal. So this real answer, once we account for the significant figures thing, is going to be called 9144.0 centimeters. Okay? Let's do another example, though. Let's see. You know what? Let's just do number 2. Number 2 is a little more interesting. It says the Bosseries have purchased an impressive press for creating apple cider at the Alba Orchard. If Megan and Nate picked 3,750 apples this past Saturday, it takes 6 crates of apples to make 10 gallons of cider. How much cider did they make? By the way, a crate holds exactly 300 apples. Alright, so this one's a little bit more interesting because there's lots of different things in it. And they're not necessarily conversion factors you go pull off a page. But the thing you gotta start with is that 3,750 apples. Okay? Now the last sentence there is the key to this next conversion factor. It says, a crate holds 300 apples. Believe it or not, that's a conversion factor. Because there are 300 apples in one crate. Apples cancels apples. Now when I look for something else, I say, okay, it says it takes 6 crates to make 10 gallons of cider. So 6.00 crates makes 10 gallons of cider. And that's 10.0 gallons of cider. Okay? Again, crates cancels crate. So I look at it, I said, okay, the problem asks us, how much cider did they make? Well, gallons of cider is what they would want. So we take it, and now you got to do the math. Now this one's a little more interesting, right? Because we end up with fractions. So 3750 times 1 times 10, that's 37500, right? Over 300 times 6, which would be 1800. So I get on my calculator and I say 37,500 divided by 1800 equals, now, we have 3 significant figures to start. I'm going to look at the number just to be sure. There's not a decimal after the 0. So this 0 is not significant. We'll talk about that later. So our answer is 3 significant figures in it. Therefore, the answer is 20.8 in the label of gallons. So there's a couple more examples of dimensional analysis problems for you. This one says in his prime, Mr. Gerbe could run at a pace of 28.0705 meters per minute. So 28.0705, and that was meters per minute. This is the first time where your conversion factor doesn't just have a 1, or what you're given doesn't just have a 1 at the bottom. This is meters per minute. So therefore the per means he's on the bottom. We want to know this in miles per hour. So we have quite a bit of work. It's probably going to take us most of this board to do it. So the first thing I do is I look on my conversions chart. Okay, it's back on, I think, page 7 in your packet here. And what you would see is 1 meter is equal to 1.094 yards. So 1 meter is 1.094 yards. Now that doesn't get me to miles per hour, right? But it cancels and puts it closer. Now, just like before, we know that there are 3 feet in 1 yard. So 1 yard has 3 feet in it. Yards cancels yards. Leave me feet. Well, still not there yet. So, when I keep doing this, I get 5,000. I know that in 1 mile, there is 5,280 feet. Feet cancels feet. So leaves me miles on the top. So I finally have miles. Now if I stopped right now, I would have miles per minute. Well, that's not what it wanted. It wanted miles per hour, right? Well, believe it or not, even though it falls way out here, we could still cancel things back. So we got to get rid of this minutes, right? And they've got to be opposites of each other, and we want something that expresses hours. Well, we know that there's 60 minutes in an hour. Well, we got to get rid of minutes. So here's what happens. We have to put the minutes on the top here because we want that minute on the top to cancel that minute on the bottom. And what is that in? It's in 1 hour. So now we end up with miles per hour. Now we got to just do our math. All right, so you do the math. You multiply the tops across, divided by the bottoms across, 1.04690 miles per hour. 6 significant figures.